The next panel today is going to be the future of artificial intelligence and sustainable development. I have Justin DeRico, Peter Gimmel, and Dennis Levine here with me somewhere. Very excited to present this panel today. The three of you guys have incredible experience within the sustainability space. So I'm very excited to explore this topic with you. So let's go ahead and why don't you guys spend a couple of minutes introducing yourselves and just giving the audience a better idea of your background. Justin, do you want to start?
Sure. Thank you, Caitlin. First, I'd just like to thank Tracy. She's done an excellent job, so let's please clap it up for her. I was sort of like bussing tables earlier, so, jack of all trades. So Justin DeRico, OTC Direct. We are an intermediary in the renewable project space, project execution space. We help medium-sized projects, small, medium-sized independent projects, technologies with financing, offtake agreements, site control, credit monetization, both voluntary and compliant. We mainly work in transportation, green plastics, which are very different than recycled plastics, a plastic based from generally agricultural waste, and green data centers. So the most relevant part to speak about today would be the green data centers. Everyone here, super bright, knows a lot more about AI and all of its capabilities than I do. But one area people don't really seem to understand, what is the feedstock? And the feedstock is universal. What is powering the green data centers? California's electricity grid is not going to be able to support it. So a lot of companies are now transitioning to different types of green solar power type of renewable energies. Microsoft, public knowledge, has recently said they might be restarting a nuclear power plant. There's been talk of coal to power these AI centers, which is kind of a bad joke, but now the AI will be able to tell you why you got cancer because of the coal. There's just a lot of problems out there with the sustainability of the electricity on the grid, and I think you'll see a large push into green data centers throughout the United States. So yeah, that's a little bit of background.
Thank you. Peter?
So I'm Peter Gamble. I'm CEO of UBLight. We're a fabless chip company, so sort of standard fare here in Silicon Valley. Our value proposition is that data per se, both the processing and transmission of data, is a gross overuse of energy and power. Our first chip uses a revolutionary architecture to reduce the power consumption in wireless data transmission by a factor of 10 relative to our competition. So relative to, say, we provide full Wi-Fi connectivity at 100 megabits per second at less than 20 milliwatts, which is around Bluetooth low energy. As we get into this panel, we'll talk about some of the power consumption issues. Our way of fixing the problem that you have is cut the power consumption. Realize that this AI processing engine consumes about 10 watts instead of 10 megawatts. And that tells you that there's something wrong with the architecture.
And Dennis?
Good afternoon. I'm Dennis Levine. I'm the CEO and founder of Water Garden Farms. And having listened to all the panelists today, I'm pleased to say we bridge almost everything I've heard. We sit at the intersection of food, water, and energy, which is something all of us need to survive. Our planet is challenged. 2 panels ago, we talked about climate change and rising temperatures, but people need to realize for every 1 degree rise in surface temperature, we lose 10% of traditional agricultural production. That's unsustainable, so we'll talk about sustainability. Population growth. 3 billion more people are coming onto a planet that can't support life today for everybody. And we talk about resource scarcity. 70% of the world's water is used in agriculture. And of that fresh water, that's only 2.5% of what's on our planet. And most of that is in aquifers and the Arctic caps. So we have real issues about how we produce food, how we consume food, how we get food to market. So we formed a company called Water Garden Farms. which addresses these issues by growing food indoors in a controlled environment where every variable is controlled by computers. And those computers use machine learning and AI to enhance productivity, which we'll get into later. And that's how we enhance sustainability, we enhance profitability, and we get food to market that's healthier, fresher, more nutritious, more consumer friendly, and better for the retailer.
Thank you all. Dennis, when you and I first met and we first chatted, one of the things that we agreed on was the importance of sustainability and profitability. Two words you don't necessarily always hear together, but in order for sustainability to advance and move forward, profitability is going to also have to tie into sustainability. So with that being said, can you please elaborate on how you're leveraging AI and technology to improve efficiency and how these changes have increased profitability?
Sure, but there's something that goes beyond that. We are going to see $50 trillion, 50 trillion with a T, flow into sustainable impact investing in the next 2 years. That's a very, very significant number. Institutional investors who have to show returns to their investors, to their limited partners, to their general partners, need to show how they make money. So in my opinion, because my background is Wall Street, my background is finance, we had to take that discipline of how do you make money and still do good things for the planet? That's what this is all about. If we show people you can actually grow things profitably and make money at the same time, then it's a win. So here's how we use AI. It's called a controlled environment. So every variable in that greenhouse is controlled. Temperature, humidity, carbon dioxide, oxygen, nutrients, water, pH balance, every component. So if we can use fewer resources to produce more food, we're answering the sustainability question. If we can use fewer resources to produce food, we're answering the profitability question. And then we take it a step further. How do we enhance our ERP system, which manages the deliveries and the interaction between our customers so that we can have on-time deliveries? We call it agrifacturing. So we can make sure we do real-time deliveries to meet consumer demand on a 20-day cycle. So we can produce in one greenhouse with 10 acres of land, the equivalent in the Salinas Valley would be over 800 acres. And we don't have to worry about floods. We don't have to worry about droughts. We don't have to worry about infestations. We don't have to worry about insects. We have mitigated the risk to produce food profitably and sustainably, not only for the United States, but something eventually we want to take to the world.
Thank you.
Yeah, Dennis, can I expand on that? Because I think it's a great point. Also in the chip business, one of the ways that we reduce the power consumption of our chips is actually making them smaller and cheaper. And in our business, at least, we hear a lot of people are paying, I would call it lip service to their ESG reports and their sustainability. But the reality is it all comes down to the price. And we are actually able to undercut the price of our competition by almost a factor of 3. Some of my investors saying I'm leaving too much money on the table, but we're doing that at above industry norm gross margins.
Well, you're just a chip off the old block.
Yeah, definitely. But I think this issue that if you have to do doing good and doing well at the same time is absolutely essential. And any play, at least in our business, that has a sustainability angle, which isn't also more profitable, is never going to fly. And that's a key part of our business.
Mm-hmm. I agree. We've seen too much greenwashing, too much purported good stuff. People don't make money. We've seen a lot of vertical farms, which everybody seems to talk about. It's a laudable concept, and there's a place for vertical farms. But in the inner city of the United States, where you have higher costs and higher inputs and higher energy and reduced capacity, it doesn't work. It works, but you can't make money, at least today. So the technology needs to evolve. And what's so fascinating to me about everything in Silicon Valley is this is where innovation happens. And our ability to harness all the things that are happening here and integrate them into our greenhouses and all industry and all business is what makes this so, so exciting for me. I will tell you, as far as AI, we have the ability, as we harness data, and it can't be done today, to do what we call a digital twin. We can actually recreate the conditions in a greenhouse and test new formulas, new nutrients, new opportunities without doing anything in the greenhouse to see if it works or not work. If it does work, you put them in the greenhouse. If it doesn't work, you pivot, you make adjustments. But it doesn't cost you anything to experiment in the digital world as opposed to the real world. And that's where this is all going. That's what will happen here as we harness this technology and as it evolves, and all of us learn how to use it.
Okay. Thank you. So, Peter, my next question is for you. You know, one of the things that we've consistently heard today has been, you know, the immense power demands that AI is having on California as well as kind of the rest of the U.S. And a lot of people are concerned for the U.S. grid capacity, and then that essentially AI, with the growth in AI, there's not going to be sufficient power to power U.S. electricity in over the next 10 years. So you alluded to it kind of in your intro speech, but can you go into more detail about how at Ubilite you're addressing both the power consumption and sustainability concerns of AI right now?
Sure. And first of all, the problem that you're discussing with power consumption is a global problem. I think AI writ large currently consumes about something like 10 or 11% of the world's energy production. I was one of the co-authors on the joint SRC-SIA decadal plan for U.S. semiconductors. At that point, we were forecasting somewhere between 2040 and 2050, the world would run out of electricity and its ability. And that's certainly, one response to that is to invest in more energy production. I think that's a backward looking, it's something you can do today, but it's kind of a backward looking approach. What you really need to do is look at the problem that you're producing, which is the transmission and processing of data in inefficient ways. So I also alluded to, we started with connectivity. That's actually the world I've lived in for 45 years, right? So that's what I know. I know how to apply data science and data transmission. It's sort of my Alcoholics Anonymous. I'm a fourth generation Wi-Fi guy, so I'll tell you, I've been doing this for a long time. So first of all, we said, chips are full of bloatware. I hate to say it because we're in a software world, but basically, a lot of the chips that people produce, probably 70% of it is things that people don't use. So when we started our company, first of all, we threw out all the bloatware. Second, people put in a lot of things that you just don't need, the customer doesn't need, you don't need, and overall it generates a very, very inefficient. And that's what I said, we were able to show 10x improvement in efficiency. So first of all, that reduces power consumption. But the other thing is, in the world I am, which is honestly, I'm in the toys and games business. So we're in our initial focus was IoT, toys and games. That's a market which by 2030, according to the latest McKinsey reports, is supposed to be 300 billion units. If you translate a 4 or 5 year battery life into that world, that means you're disposing of 100 million single-use batteries per day. Pretty big environmental impact. We showed that just by applying our first generation chip, you could reduce that by something like 50 million single-use batteries per day. Our roadmap actually shows that we can produce chips that are completely passive and ambient energy harvesting. So you can move to an IoT that doesn't use any batteries, get our power consumption down to the 1 to 3 milliwatts, that range, anything, ambient light, vibration, 3 milliwatts you can get pretty much from anywhere. So it allows you to save the batteries, it saves the installation, the maintenance costs, also allows you to apply IoT nodes anywhere. And again, to point to what Dennis is doing, I'm one of the members of the FCC task force on precision agriculture. And we're running into a problem with data transmission in the United States, where a lot of the data, when you're talking about precision agriculture, is coming from places where there are no people. But the networks have not been deployed in a way that there's actually high-speed data. So if you put a greenhouse or a farm in the middle of nowhere and it's pulling all this data back to the data center, right, there's actually no cost-effective way currently to actually move that data from the greenhouse to the data center. Another problem that we're working on with our chips, because we now can do long-range efficient data transfer. But that's going to be this issue about, as we grow AI and more things that are not people start generating data, you really have to start thinking about the data backbone, at least in the United States. And I'll give the FCC some credit to actually having started those initiatives.
Well, thank you. So Dennis, you threw out quite a large number that is projected to be, invested within the sustainable world here over the next several years. And so, Justin, my question for you is, there's not a lot of regulations or consistency within the sustainable development world. So how do you think AI-driven insights can help policymakers create more effective sustainability regulations and policies?
Excellent question. So you have to start at the core and beginning. Carbon credits were ripe with fraud, as Dennis mentioned, greenwashing. So now corporates need an immutable audit trail of the process of how that product was produced. And the problem with that is in the voluntary market, there's no central agency. It's just broken up to .orgs and think tanks. And while a lot of these people are very smart people, a lot of them are very arrogant, unfortunately, and they don't work together. So if you're in the chemical industry making green chemicals, you have to get certified by ISCC. If you're an airline using sustainable aviation fuel, you have to use CORSIA and RSB. If you're in agriculture and like sugarcane, for example, you have to use Bonsucra. So there's all these different agencies that don't work together, and they are also the ones essentially playing God, writing the rules of how these certificates for decarbonization for scope 1 and 3, need to be met. If you buy a stock, where is it held? At your bank. It's held at E-Trade or Morgan Stanley, wherever, right? If you buy one of these certificates in the voluntary market, they're held at these organizations on their depository. It makes no sense. These people, while very smart, they don't have a business skill set. They don't have any business acumen for the last 20 years because they've been living off of donations. The whole structure of it needs to be changed. It needs to be held at Bank of America, JP Morgan, Goldman, wherever you want. And these organizations need to oversee it like the SEC and FINRA oversee the market dynamics now. It needs an open marketplace. It doesn't matter what I think a SAF certificate, a sustainable aviation fuel certificate is worth. Doesn't matter what you think about it. The market decides. And these companies, organizations, .orgs, and think tanks are the ones deciding the prices. It's a broken system right now, and it needs to be reset. And I agree with their points of it needs an immutable audit trail, because if Microsoft buys a SAF certificate, it needs to have an audit trail of the process of how that gallon of sustainable aviation fuel is produced. No one's arguing that, but it needs to go back to the core. And then answering your question, I got off topic, there's no data, right? How are you going to improve the current structure of all these the voluntary market if no one is sharing data? Microsoft, it's public news, on LinkedIn, they bought a ton of SAF certificates from World Energy. There's no price discovery. No one knows what the price is. No one knows what the underlying parameters of the structure of those are. It was a large number. So the more transparency the market can have, the more AI can improve the processes across the board in order to have a transparent view of how a company needs to produce a gallon of fuel, what that carbon intensity score is to show exactly what the output is. For example, jet fuel has a carbon intensity score of 80 to 90. Ethanol has a carbon intensity score of 70. Renewable diesel, which everyone thinks is great, is still plus 30. There's cellulosic proven processes out there through pyrolysis, through electrolysis, through gasification, using agricultural waste that can get carbon intensity scores minus 300. That's with carbon sequestration. That's a whole nother argument, but each his own on that. But there's proven ways that they could commercially, entrepreneurs and scientists can get these on the mass market if there was some organization and one general overseer of how the processes need to work.
As a matter of fact, Justin and I had a conversation last night. He said, man, what you do is so cool. We can take agricultural waste and use it to make fuel. How much waste do you have? I said, none. Oh. I said, the beautiful thing about what we do is it has over 99% throughput. What we plant, we harvest, and we harvest 365 days a year. We get product to market within 6 hours. And it's sealed. There's been absolutely no human touches. has an 85% decarbonization component and a 60% EBITDA margin. That's how we address sustainability and profitability in a compelling business model that addresses food insecurity on a global level.
Thank you. So it's been publicized that about 80% of the top companies throughout the world are largely set to fail their climate goals. And with trillions projected to come into the sustainability space, to sustainable technology space over the next several years, obviously that is going to create some innovation. However, that's going to take many years for that to see itself through. So currently, how do you guys think AI can help businesses and industries transition to more sustainable models?
I'd like to kick that off. I think having that data to let a company know what their decarbonization will cost their shareholders in 2030, 2035, and 2040, that will be the answer. Right now, the market is a spot market on these forward obligations and contracts that don't have any data. If those commitments and those prices were forecasted and made public of what it costs to decarbonize, then you can answer your shareholders like, hey, this is what it's going to cost. This is what we're going to do. People can forecast their decarbonization goals for today, maybe 18 months out, but I think that's a stretch. But no one has any idea what it's going to cost to go net zero in 2030, 2035. They're making it up if they tell you they can.
Regrettably, that's true. And anybody that thinks that this battleship can turn overnight and that we can go to this data point is delusional. It will take time. It will take lessons. And AI is a tool, but it's a nascent tool. And all of us are learning how to work it. And AI is only as good as the data that you put into it. So it's an old saying in the data world, garbage in, garbage out. So we need to refine the data, the access to the data that you just talked about, to make sure that decision makers are being assisted by AI. AI is not making the decision, but giving the decision maker the tools to make the proper choices to address some of these climate goals.
Peter, do you want to add anything to that?
Well, of course, in chip design, we're in a world where AI is really nothing new to us, right? People ask, what's the impact of AI on the chip design? I said, well, 95% of what I do is already done by a machine. So it will increase, but it's already 95%. I will say that the application of machine learning and AI to especially radio frequency chip design has shown about a 30% productivity improvement, both in terms of chip size as well as man hours to architect the chips. Also, in terms of the factories that we use to produce the chips, it's also about a 30% impact. So not the kind of dramatic impacts you're seeing in some of these other industries, partially because chip design has been embracing machine learning and various types of data sets for a long time, but there is still a significant impact. I said, especially in the radio frequency part of the chip, so about a 30% reduction in chip size. And if you're trying to make money, the 30% improvement, which is sort of half that, so 15% improvement in gross margins is a pretty good number to tell your investors.
All right, well, I think that's all the time we have for today. Thank you all.